So you've probably heard the name Databricks thrown around, right? And you might be wondering, what exactly is it? Well, you're in the right place. Over the next few minutes, we are going to completely demystify this super powerful data tool. We're going to break down what it does, how it works, and we'll use some really simple everyday analogies to make sure it all just clicks.
All right, here's what we've got on tap. First, we'll tackle the big data problem itself. Then we'll see how Databricks swoops in like a magical workshop. We'll uncover the secret to its speed, which is all about teamwork. Then we'll see it in action with a real-world example, explore its awesome all-in-one storage system, and finally, we'll get you pointed in the right direction to start your own Databricks journey.
Okay, let's jump right in. To really get why a tool like Databricks is such a big deal, you first got to understand the problem it was built to solve. I mean, why does it even exist in the first place?
You know that feeling when you're just completely swamped, like information overload? Well, imagine that, but for a huge company, and multiply it by 1,000,000. That right there is the heart of the big data problem. We're not just talking about a little extra info, we're talking about an absolute ocean of it.
Yeah, see, in the real world, data is rarely neat and tidy. Oh no, it's messy, it's all over the place, and there's just so much of it. It's kind of like trying to sort a gazillion Lego pieces by color, all by yourself, from a giant toy box. It's just a huge, chaotic pile.
And that's really the breaking point, isn't it? When you get to that kind of scale, a single computer, I don't care how powerful it is, it just can't keep up. It's going to be painfully slow, super inefficient, and honestly, it'll probably just give up and crash under all that pressure.
So if one person or one computer can't handle the job, what do we do? How do we possibly tackle this massive data problem? Well, the answer is you need two things: a totally specialized environment and a really clear process.
And that's where Databricks comes in. The best way to think of it is like this magical high-tech workshop. It's the perfect space, already set up with all the tools, all the helpers you could ever need to deal with those millions of Legos or thousands of papers. It makes the impossible possible.
Yeah, the actual work that gets done inside this magical workshop, that has a name. It's called data engineering. It's really the art and science of taking all that messy, raw data and turning it into something useful, organized, and, well, valuable.
And you know what? We can break down this whole process with a super simple analogy. Running a lemonade stand. Seriously. First, you collect your raw data. That's squeezing the lemons. Then, you clean it up, filtering out all the seeds. Next, you transform it by mixing in sugar and water. And finally, you serve a finished product, the cold lemonade, which is your useful information.
Okay, so this workshop sounds great, but how is it so unbelievably fast? What's the secret sauce? Well, it's not some single superpowered machine. The real secret is teamwork.
Think about it this way. Let's say you had to build a huge sandcastle. Would you rather do it all by yourself or have 10 friends helping you out? With friends, right? It's way faster and a lot more fun. That exact same idea is how Databricks gets its speed. It uses teamwork, and in the Databricks world, that team is called a cluster.
Yep, a cluster is literally that team of friends. Instead of one computer trying to do everything, Databricks brings in a whole team of computers, gets them all coordinated, divides up the big job, and they all work together to get it done super fast. And this isn't just a random group of computers, it's a highly organized team. A great way to picture it is like a professional restaurant kitchen. You've got the driver node, that's your head chef. The chef comes up with the plan and tells everyone what to do. Then you have the worker nodes, that's your line cooks. They're the ones who actually do all the chopping and cooking all at the same time. And we can take that kitchen analogy even one step further. Each of those worker computers has multiple cores. Think of a core as a pizza oven in your kitchen. If you have 4 ovens, you can cook 4 pizzas at the same time, right? It's the same idea. The more cores a worker has, the more things it can do at once. All right, so we've got our workshop, we've got our team of chefs in the kitchen. Let's put them to the test. Let's see what happens when we give them a truly massive job, like analyzing terabytes of data from the real world.
So imagine an e-commerce company needs to figure out its total sales for each region, and they have a whopping 5 terabytes of data. Here's how it goes down. First, the driver node, our head chef, breaks that huge job into smaller pieces and hands them out. Then, all the worker nodes read their chunk of data at the exact same time. Next, they do this really important dance called the shuffle to get the data organized. After that, each worker can calculate its part of the result. And finally, the driver node gathers up all those answers to give us the final complete number.
Okay, let's zoom in on that shuffle step because it's super important. Before the shuffle happens, each worker has a totally random mix of data. Worker 1 might have a few sales from the north region, a few from the south, some from the east. It's all jumbled up. So it can't possibly figure out the total sales for just the north region, right? It doesn't have all the pieces.
And that's why they need to shuffle. This is the moment where the real teamwork, the real magic happens. All those worker computers start talking to each other, passing data back and forth, and completely reorganizing it so that each one can do its job properly.
And boom, after the shuffle is done, everything is perfectly organized. Worker 1 now has all the data for the north region. Worker 2 has all the data for the south, and you get the picture. Now they can all crunch their numbers at the exact same time, in parallel, to get their part of the answer.
So, the big question is, how long does all of this take? Processing 5 terabytes of data. With this incredible teamwork, it's done in about 2 minutes. Yeah, just 2 minutes.
Now, just for a second, let's compare that to one of those big, powerful single computers trying to do the same job. Our best guess? It would take around 12 hours. And that's being optimistic. That's if it doesn't just run out of memory and crash halfway through. I mean, the difference is just staggering, right?
But you know what? All that crazy fast processing power is really only half the story. Because to really get the most out of your data, you also need a brilliant way to store and manage it. And this is where Databricks brings out its biggest innovation of all, something they call the Lakehouse.
So to really get why the Lakehouse is such a game changer, you have to look at how things used to be done. On one hand, you had the data warehouse. Think of this like a perfectly organized library. It's super fast for finding specific information, but it's really expensive and super picky. It only accepts neatly structured books. Then on the other hand, you had the data lake. And this is more like a messy garage. It's cheap, you can throw literally anything in there, videos, text files, you name it, but good luck finding anything useful. It's slow and totally unreliable. So what does the Databricks Lakehouse do? Well, it gives you the best of both. You get the cheap, store-anything flexibility of the garage, but with the organization, speed, and reliability of the library. And this is a huge deal, because it means everyone in a company can work from the same data at the same time, finally breaking down those walls that used to exist.
Okay, so let's recap. We've talked about the big data problem, the magical workshop solution, the teamwork engine that makes it so fast, and the amazing storage system. At this point, you should have a really solid idea of what Databricks is all about. So, what's next for you? Well, the most logical step is to try it yourself.
Look, the absolute best way to learn this stuff is by actually doing it, by getting your hands dirty. And the really great news here is that Databricks has a totally free community edition. It's basically a free playground where you can go in, experiment, and start building your own cool data projects.
So if there's one thing to take away from all this, it's that the tools to build amazing things with data are more accessible right now than they have ever been. You've now got the keys to the magical workshop and an infinite supply of Legos. So the only real question left is, what amazing structures are you going to build?